Hi, this is Arthur for the Tezos Dev Update of November 24th. So happy Thanksgiving to our American friends. This is going to be a fairly quick dev update. It's mostly background work. One of the main changes you will see is that the AlphaNet is going to be a lot more stable. So we fixed some regression, and so it should be working fairly well now. And we're keeping hardening it. So one thing you have to bear in mind is just because the AlphaNet is working, you can do contracts, you can do all of these things, doesn't mean it's quite ready. Things obviously once you launch are getting a lot more adversarial, and right now we don't have a very adversarial environment. Fortunately, some people who are using the AlphaNet are playing with it. They're putting very large operation, or we had some people try to spam the chain with faucets. So that's great. This is helping us a lot, obviously. So in order to control spam, one of the things that we have is we have controls at different levels, and so one that we added this last week was a contract on the maximum size and number of operation inside a block. So in principle, you could say that the size of the operation is bound by the size of the block, and that should be enough. But it's better to put controls that are at many levels. And like I've explained before, we'd rather have a lot of controls that restricts things so that we know that we're safe, and then progressively loosen them. And so tentatively, we set it at 16 kilobyte for a transaction, maximum size, and 300 transactions per block. This is going to change. This is just for the this is just going to be in the next version of the AlphaNet. What the parameters are, they need tuning. On my end, I'm working on several things, mostly describing the proof of stake algorithm and hardening it. So I had been working on PVSS. So it hasn't been merged, but it's been written and tested. The other things that I'm working on is hardening the way that we derive the public seed. So there's a seed that's calculated every cycle that is a random seed. So one thing we do to harden it is use this PVSS procedure so that different participants can help reconstruct those secrets. Another way is to make it expensive to compute a seed. Now you want to make it expensive to compute a seed, but you also want to make it very cheap to verify that the seed has been computed as the right one. In order to do that, you need to generate a problem that's easy to check, hard to solve, easy to generate, and which has a unique solution. And so but what we're doing is we're generating a discrete logarithm problem, and the solution to the discrete logarithm problem is the seed. So it's a minimal amount of proof of work. It's very small compared to the type of proof of work that would go into a pure proof of work blockchain, but nonetheless, it prevents it does put a wrench in grinding. Now, in theory, with PVSS, with the economic incentive, we don't need this. But I like a belt and suspender approach and trying to add as many layers of protection as possible. In terms of other dev updates, we're working on a binary protocol for the RPCs. So you notice that sometimes the RPC in JSON can take a while to respond if you have a big piece of data. Like we had a 2009 contract, for example, that was taking quite a bit, and most of it is parsed in JSON. So Milo has been working on reviving the binary protocol, which lets you talk directly in binary to the node. This is going to be particularly helpful for bakers, because when a baker talks to a node right now, they're dumping the entire melt pool, the entire set of transactions. It's all being dumped in JSON, and so that's being passed now in binary. That should be make it baking a lot more efficient than before. So like I said, mostly background work. We had a meeting on the calling convention as well on Michelson. So right now we have this system in Michelson where you're basically can only call another contract once you've cleared your stack, but you can keep the program point. So you keep where you are at the point of the execution of your contract, then you call other things. And so we were thinking through this model, and there are various ideas that are floated around. And I think the one that we're converging towards is that instead of treating calling other contract as some sort of function call, what we're going to do is we're going to have the contract actually return a list of operations. So just like a regular transaction, basically the contract outputs this list of transactions, which are going to be put inside a queue, and in that queue, then they're executed in this order. And so that makes it not as straightforward to write code that just does like jumps and function calls in many contracts, but it also makes it a lot harder to shoot yourself in the foot. Now, I actually don't think that I don't really like the model of treating other contracts as some sort of libraries. I think that if we want to do that, you're better off using memory sharing or even increasing the primitives that are available to the smart contract language. So it forces you to think, of course, of the contract as almost being asynchronous, which I think is a helpful way of avoiding some of the bugs that happen with smart contracts. Anyway, that's all for the update this week. I think we're going to be merging a lot more stuff next week, so there'll be more to talk about. I'm also doing a meetup on Thursday in Zurich, so if you're around, I will be at the Bitcoin meetup, and I will be discussing a little more about the current development of the dev team in Paris, and also some of the community work that I'm pretty excited about. Till then,